Okay, so today I'm going to talk about sections 3.1 and 3.2. This lecture doesn't have any students in, so it's just going to be me, and I'm going to be talking to myself. So hopefully I don't make any mistakes in the process. Sections 3.1 and 3.2. Sticking with working with degrees up to this point was great, but now we need to be able to switch to something called radian measures, because we can talk about an angle and all these different trig functions dealing with a circle, either with degrees or with something called radians. So what we need to do today is start out and figure out what is a radian, and in what way can I convert back and forth. Section 3.2 is going to be arc length of a circle and area of a circle. Believe it or not, once we start getting into this, you're going to be going like, okay, I got the idea of some of these formulas that you've had back in the old days and where they've come from. Because a lot of math, you're just given what it is, but you never knew where, for example, the area of a circle is pi r squared. And you get that when you take calculus. You'll see a small proof. But we're going to be able to prove a couple of other things. So today I took my trusty, I have no affiliation with the St. Joe's Hawks. I could turn it this way. But I had this shape, and I thought, well, I'm going to demonstrate what's really going on. So the first thing was I took my ruler, and I tried to go straight across. And when I did, I found out that straight across is 8 inches. Well, in your world, hopefully you remember some of the terminology, and this is actually called the diameter. It's all the way across, and it's 8 inches. And some of you are now going, yeah, I know the diameter, but I'm used to working more with just this much, which would be half of the diameter, which is the radius. And in fact, that's true because almost everything we do in trig, we talk about the radius. So I took that and went straight across, and I'm happy. And I had 8 inches and 4 inches, and you have no idea where I'm going with this so far. Then I took the circle and I took my ruler. Okay. My ruler is really hard to see because it's clear, but I started at a point on my circle, and it's easier for me to show you here. Okay, I started it, and then I slowly rolled my circle down, and I kept measuring until I got all the way around to where I started. So what I'm saying is I went and started at a point right here, and I went all the way around the circle. Well, a lot of you know there is a name for that, and it's called the circumference. And when I measured it, my circumference came out to be just a tad over 25 inches. In fact, it was so exact, my ruler, I mean, it's a heck of a ruler. I counted it that it was 25.1372 inches all the way around that circle. So if I started here, all the way around the circle, and you know it's circumference. And some of you even know that, yeah, there's some kind of, well, if I take my calculator and turn it on and say, hey, calculator, let's clear, oh, there's trig stuff on there already. I'm going to take my calculator and say, well, that 25 is an interesting number. And I wonder how it's related to the diameter or the radius. So I took the 25.1372, and I thought, well, okay, I'm going to divide it by 8. And all of a sudden, I got 3.14. I know what that is. That's pi. I came up with, and this is what you should have come up with, circumference equals pi times the diameter. Huh. Well, I'm going to take that one step farther and say, well, we don't work with the diameter a lot. We work with the radius more. So all the way around is pi times diameter, which is really 2 times the radius. And all of a sudden you're going, yeah, we've seen that 2 pi r is the circumference. That was the formula for all the way around. And again, I measured all the way around my circle and I divided it by the diameter, and I did in fact get pi. Then I just replaced diameter with 2r. So this is where that formula comes from, and it's definitely something we're not going to throw away. So circumference equals, and we're saying now that it's 2 pi r. All right, well, my radius right now is 4. So if I put 4 in, yeah, I would get a circumference of what I was talking about over on this side of the page, the 21.327. But what if my radius was just 1? What if my radius was just 1? Well, then my circumference would be 2 pi. So when I use a radius of 1, when radius equals 1, it's called the unit circle. And you're going to hear this term quite a bit in the course. When the radius is 1, it's the unit circle. And when I start talking about the unit circle and the radius is 1, I know that all the way around is 2 pi. But I also know in angle measure, we get into this whole 360 degrees things, okay? And this 2 pi really doesn't have a label right now. And that 2 pi is something called a radian. So right now, a radian is a unit of measure. Okay, radian is just a unit of measure. Unit of measure. And when I start working with this, I find out that all the way around the circle is going to be 2 pi radians. And a lot of times you won't see the word radian. And if you don't see the degree like we're used to, you know it's radians. So now all of a sudden I'm saying, wait, 2 pi radians is all the way around, but so is 360 degrees. Well, that's going to help us out considerably, because that's going to be my key to do conversions from degrees to radians or radians to degrees. So I have this in my world. 2 pi equals 360 degrees. And in fact, some of you are going, well, that's really familiar to me, because I also know that 1 pi, that's halfway around, is 180 degrees. So if I have that as a fact, and I say, okay, I want to do conversions now. Well, I want to go from degrees to radians. I'm going to multiply. I'm going to put the degree label in the denominator so they cancel. And up in the numerator, I'd have radians. And to do the conversion, I can say, you know, I didn't have to put the word, but pi radians is the same as 180 degrees. Well, I already had a degree in there, which means that 45, that's not a 5, 45 pi over 180 is the same as 45 degrees. But I can, in fact, simplify that, and it becomes pi over 4. So 45 degrees is pi over 4 radians. Let's do it again. I'm going to multiply by 1. And my 1 is going to be pi radians over 180 degrees. Degrees and degrees. So in the numerator, my exact value would be 249.8 radians, excuse me, pi over 180 radians. And again, if the label isn't there, it's assumed to be radians. So that would be the exact, a lot of times we'll clean that up, multiply by 3.1415926535897 divided by 180 to get an answer. But if the question says exact answer, leave it with pi in there. All right, let's go a different direction. What if I have radians? There's no label, and I want to convert it to degrees, which means in the numerator, I'm going to use that 180 degree again. In the denominator, I'm going to put the pi. So radians up here and radians down there cancel. Pi and pi cancel. Now I'm going to get 9 times 9 over 4 times 180 degrees. 4 goes into 180 like 45 times. So now I get 9 times 45 degrees. And we're going to figure that out. 9 times 5 is 45. 9 times 4 is 36. Plus the 4, 405 degrees. So 9 pi over 4. Oh, cool. Little side note. 8 pi over 4 is the same as 2 pi. So this guy actually went all the way around and another 45 degrees. Oh yeah, that's a coterminal angle with 405, because if I go around 360 and then another 45. Cool, awesome sauce. Same thing. I want degrees, so degrees in the top, radians in the bottom. I'm going to ask Siri for help. Siri, hey Siri, what is 4.25 times 180? 4.25
times 180 is 765.
Hey Siri, what is 765 divided by pi?
765 divided by 3.1415 is about 243.507.
Oops. Pardon me. Degrees. We had started with radians and we ended up with degrees. Okay, so I'm going to come over to this page and just some things to take a look at. These are ones that you're going to see come up a lot. Oh, I almost made it. Graph theory problem. These are popular ones. And again, 30 degrees is pi over 6 radians. Why? I took 30 degrees times pi over 180. And again, I could have used 2 pi over 360. That doesn't matter. The degrees cancel. 30 and 180 cancel. It becomes pi over 6. And I could have done that to all of these. But this is a nice fact to have, because we can use that all the time. I almost said, are there any questions? But clearly there aren't. So let me give you a question here. I now would like you to find, we're going to figure out how to do the tangent of 2 pi over 3. Well, oh, that's crooked. 2 pi over 3. I'm not used to 2 pi over 3, so I'm going to do a little side work. 2 pi over 3 is radians. I'd like it to become degrees. So I have the 180. The pi's cancel. This ends up being 120 degrees. So now my problem looks a little more familiar. The tangent of 120 degrees. And right away, I go back to my circle and I'm going to go 120 degrees, which is going to be 60 short of 180. And then I go, okay, I am familiar with my 30, 60, 90. That's the 1 square root of 3, 2. By location, this becomes -1. So the tangent of this reference angle is opposite over adjacent, square root of 3 over -1, or simply negative square root of 3. Now, I keep saying in some of the previous videos about building blocks, you know, and now all of a sudden, this is something that we've learned and we're we learned where to draw this. We learned the 360, 90. Now we can take the tangent of 2 pi. So it took us a while to get here, but putting all those pieces together. I think I'm going to take a look at one more. And this time, let's do the sine of 3 pi over 2. So bringing into play what we did today. 3 pi over 2 times 180 over pi. I think that's going to give me the 2, and that become a 90. The pi's cancel. 3 times 90 is 270 degrees. So now my problem is going to be the sine of 270 degrees. Like before, I'm going to draw my reference angle, goes past 90, it goes past 180. In fact, it goes all the way down to here to 270 degrees. Okay, this is good. We haven't done one of these problems in a while. When I take a look at this, I know that this is the ordered pair 0, -1. So this gives me x equals 0, y equals -1. And now I need to find my r. 0 squared plus 1. So it looks like my radius is going to be 1. So now when I do my sine, just putting pieces together, this was x, this was y, and this was r. Sine was SOHCAHTOA, opposite over hypotenuse. It's going to be y over r, -1 over 1, which gives me -1. Good problem to do. Something that we haven't done in a while is land on one of those angles that are located on either the x or the y axis. But again, I looked at the ordered pair, 0, -1. I calculated r by thinking about what it would look like as a triangle, opposite over hypotenuse. Again, I'd like to ask questions, see if there are any questions, but I know there aren't. So now I'm going to move on to section 3.2. 3.2, I'm going to talk about something called the arc length first, and my circle got a little wobbly. Wasn't bad to start, but it went downhill pretty quick. So the arc length is my all the way around. And when I talk about my arc length all the way around, I know that I have the formula circumference equals 2 pi r. But what if I didn't want to go all the way around? What if I wanted to take a look at this circle, and instead of all the way around, I wanted to go this far around? So I wanted to find the arc length of that region. Okay, and I'm going to say that this is, well, let's think about this for a second. So when I'm dealing with 2 pi over here, I'm dealing with radians. Okay, so I have to be careful. I need to know what this angle measure is, and I need to know what the radius is. Because if I had the radius, if I had all the way around, it would be 2 pi, I can find the circumference. But I don't want to go all the way around. I want to go part way around. Well, let's say this is 45 degrees, and I have a radius of 2. All right, no, that's not right. That's not going to help me. I need to find arc length. Arc length is denoted by the letter S. Okay, that's good. I don't have 2 pi. Instead, I have 45 degrees. But I do have R. So I'm missing something in here, and I'm going to need something that goes in there. Well, we're actually going to call this theta. S equals theta R. And theta is going to be the angle measure. So instead of going all the way around 2 pi, I'm only going to go part way around. So theta is the angle measure. And here's the asterisk, in radians. So if I took this circle and its radius was 2 inches, And then I took my ruler and measured around that much. I'd be able to find out how it is by using this S equals theta R. Well, let's see, 45 degrees. I'm going to come over here real quick. 45, I'm going to go inside. 45 degrees equals, I know this one because I've done it a lot, pi over 4. Okay, that was on the last page that I showed you. It's going to be a common one, and start thinking about it in that manner. So now I'm going to say the arc length equals theta in radians, pi over 4 times radius times 2. And I'm going to end up with an exact value of 2 pi over 4, or pi over 2 radians. That's how long this would be. So if I had a circle with a radius 2, and I only went around 45 degrees, that length should be, well, let's see, pi is 3.14 divided by 2. It's like 1.5 inches. We start going around. Right. It must be in radians. Okay, good. I got all that. All right. So what if I went back to my original big thing here, right? I have this big guy, and that big guy I know has a radius of 8. I wonder how far it would be if I cut this in half, if I went halfway around. So if I decided to go halfway around, I know that my radius is 8. My theta originally, I know it to be 180 degrees is halfway down. But now that I'm learning this thing called radians, I know it's going to be pi. Okay, so I'm going to say, all right, arc length, S equals theta R. S equals pi times 8, which is 8 pi, which is, excuse me, oh my goodness, my big circle had a radius of 4. It had a circumference. Let me fix this up. It's good I'm doing it in pencil today. So that's 4 pi, which, hey Siri, what is 4 times pi?
4 times 3.1415 is about 12.5663.
Inches. Inches. So if I went around, that's what it'd be in inches. Okay. So this has become a big formula for us. First one, arc length. Where does it come from? Instead of all the way around, I only want to go part way around. All the way around is 2 pi radians. This time I only want to go around a certain amount of radians. Sometimes it's going to be given to me in degrees, like over here. So the first thing we're going to have to do is convert it and get it into radians. Second part of 3.2 is something called the area of a circle. So now I'm going to build on something I already know. Up above, I knew, I knew that circumference equal 2 pi r. And the only other thing I really know about a circle is that, well, this is the word area, and the area of a circle is pi r squared. Oh man, too bad that's not 2 pi, because if I want a sector, the area of a sector, I don't want to go all the way around. I only want to know part way around. Looks kind of like a windshield wiper. What's the area covered by that windshield wiper kind of deal? Well, I can use math magic and say, wait a minute, I replaced 2 pi, which was all the way around, with how far I wanted to go around. So now I'm going to do this. I'm going to say, well, if I multiply by 2, I also have to divide by 2. Now I'm in a situation where I can say, hey, here we go again. Instead of going all the way around, I only want to go theta around. So I'm going to replace the 2 pi with theta, and now I get this ever popular formula, area of a sector. and it's going to take me part way around. And again, I started with the area of a circle, something you already know. I said, oh, if it was only 2 pi like up in the previous problem, I can replace it with theta, how far I go around. Well, I can make it 2. I can multiply by 2 and divide by 2. I can take that 2 pi, pull it out, and I'm left with the theta in there. So woohoo! Got the idea? All right, so let's take a look at a problem. I have a pizza, you know, and it's a 9-inch pizza. So an example, I have a pizza. The pizza is 9 inches. Okay, a pizza is 8 slices. Good. 6 slices were just eaten. There are 2 left. What's the area of that sector that's left? What? I'm going to write my formula. Area equals theta r squared over 2. All right. It's a 9-inch pizza. You like my accent? So I know that from my notes, r is going to have to equal 9 inches is all the way across. 9 over 2 inches is my radius. Okay. My theta, let's see, there were 8 slices. I'm going to draw it. There were 8 slices. Pow, 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 pow. 6 of them were eaten, and there's only 2 left. Well, 2 out of 8 is the same as 1/4. Well, if I went 360 degrees and I divided that by 8, that would be the angle measure of each slice of pizza. So 8 into 360 degrees actually equals 45 degrees. But we have 2 slices left. So I'm going to now make this 90. Well, I don't want to say equals. So now I know my theta equals 90 degrees with the 2 slices left. And of course, I'm going, no, times pi over 180 degrees gives me pi over 2. Area equals pi over 2 times r squared. R is 9.2 inches squared divided by 2. I need to keep my notes up here, keep things separated. Didn't leave myself enough room. So this is going to become, I'm going to square this. So that's going to become 81 over 4. So I'm going to have 81 pi over 4, over 8. I square this to give me 4 times 2 is 8. Then that's divided by 2. Inches squared. Well, I've run out of room. So now I'm going to have to draw an arrow. I'm going to come over into here. And I know if I divide by 2, that's the same as multiplying by 1/2. So now I get 81 pi over 16 inches squared. Hey Siri, what is 81 times pi divided by 16?
81 times 3.1415 divided by 16 is about 15.9043.
Inches squared. So that's how much pizza's left. And of course, where does that come into play? Well, you know, you're covering a pizza with cheese or pepperonis, and you want to figure out how many pepperonis you can get on, or on and on and on and on. But this is the area of a sector. This formula looks like blah, but you know the area of the whole thing is pi r squared. The slight trick, multiply top and bottom by 2. replace the 2 pi with theta, and you're there. Never have to memorize it for the test, just the process. Arc length, same as circumference, except instead of 2 pi radians, I go theta radians and convert it around. So I'm sure you have some questions. I will gladly take any emails or anything you might have. Or you can bring up any questions the next time we meet. So I hope you liked my explanation. I'll see you soon.